Okay, this is a tutorial about how to use NetworkX. Okay, so NetworkX is a Python package that's useful for handling graphs or networks. So if you'll recall, at the most basic level, a graph consists of some vertices that are connected by edges. And these will be useful for the course project. Okay, so to use NetworkX, so the first step, I would say, is go to Canvas, go to the Python related resources module, and then there should be a link for NetworkX examples. Click on that. It should take you to a GitHub repository. And if you've never used GitHub before, I'd say maybe the easiest way to get the files that are here is to, let's see. There should be a way to download the entire repository. Let's see. Okay, so we'll click on code, this green box, and then click download zip. And it'll down everything in this repository. Okay. Then I should switch screens. Anyway, so it should download a zip file. Then go to your downloads and open up that zip file. Maybe I can share my screen. Okay. So in my downloads, I clicked on the zip file, I unzipped it, and then I'm inside of it now. So you should have all of these files on your computer in downloads. If you'd like, you can move this, essentially this folder to a different location on your computer. I'm just going to leave it here for now. Okay, so after you've downloaded this, your next step will be to open up Jupyter Notebook. So open up Jupyter Notebook. And then I'm going to navigate to wherever that zip file is that I just unzipped. So in my case, it should be in downloads. And then let's see. Okay, here's the unzipped folder. So I'll go in here and I'll go to starters. And this first NetworkX tutorial, I'll click on NX1. Okay. So we're going to use NetworkX to create a very simple graph that's just vertices 1, 2, 3, 4, with an edge between 1 and 2, between 2 and 3, and between 3 and 4. Okay, so but before I do that, I should import NetworkX as NX. So I'll run that first cell. Okay, and the cell has successfully run. Should have a 1 next to it. I think NetworkX is automatically installed as part of whenever you get Anaconda. So it should already be part of your installation. Okay, so we're now going to create a graph, and we're going to call it G for graph, and it's going to be a NetworkX object. So nx.graph. So this is just kind of a graph that has nothing in it. So it should have no vertices, it should have no edges in it. So let's check that. So far, the graph G has nodes G dot nodes and edges G dot edges. I'll run that cell, and it says the nodes, it's just this empty list, and the edges are just an empty list. Okay. Next, I want to add these nodes 1, 2, 3, 4. So one way I can do this is just to do G dot add node 1, G dot add node 2, 3, and 4. And just to see what G looks like at that point, I'll go ahead and print again. Okay. So the nodes are 1, 2, 3, 4, and there's still no edges. So now let's add some edges. G dot add edge. And now we just need to specify what are the endpoints of these edges. So 1 and 2 is an edge. 2 to 3 is an edge. And 3 to 4 is an edge. This graph that we're trying to build. So I'll copy this, print that. Okay. So you'll see I still have those 4 vertices, and now I have my edges. So everything seems to be going properly. We can also ask how many nodes are there in this graph and how many edges are there. So at the end, the number of nodes is, and then here we'll go G dot number of nodes. And this is actually a function, so I need to open and close parentheses. And the number of edges is G dot number of edges. So it should be 4 nodes and 3 edges. Cool. Okay. We can then ask other questions like, in our graph, which nodes neighbor node 1 or touch node 1? And so that should just be node 2. That's the only one that neighbors node 1. So to get that, we can just say this. The neighbors of node 1 are, and usually you would refer to this as G dot neighbors. Oops. Neighbors of 1. But I think if we run this, we're going to have a problem. So the way that NetworkX is referring to these neighbors, it's actually not like an array that's explicitly stored in the graph object. This is almost like a function or an iterator. So it doesn't make sense to print exactly this, but if we were to just tell Python to convert whatever's there into a list, then it will be able to print. Okay. And so now it correctly shows that 2 is the only neighbor of node 1. We can ask the same question for node 2. So we should have 2 of them here now. So we should have node 1 and node 3. They should both be neighbors. And that's what it says. Okay. So that's one way to create this graph and refer to some of its attributes. But NetworkX also has a lot of functions that are built in that will allow you to build graphs of special types. And in particular, this graph that we just built is what's called a path graph. And so we can actually build this in one step in NetworkX by doing this. That'll create a path graph on 4 vertices. And we'll just print out some information about this graph. The graph H has nodes I'll do h.nodes and edges h.edges. Okay, and you'll see here we have 4 nodes and we have our 3 edges, but the numbering's a little bit different. So like a lot of things in Python, they start the numbering at 0. So that's why this is 0, 1, 2, 3. Okay. So those are just the basics about how to build graphs in NetworkX. And in all of those cases, the nodes were numbered. So we had a node 1, a node 2, node 3, and so on. But when you're working with these instances for the project, it may be helpful to have names that are a little bit more descriptive. So we're going to build the graph for Delaware. I'll put up on Wikipedia. So Delaware has just 3 counties: Newcastle, Kent, and Sussex. And so the graph here is actually very simple. It's another path graph. So Newcastle touches Kent County, and Kent County also touches Sussex County. So it's a path graph on 3 nodes. So let's build this graph. So I'm going to call this graph G sub Delaware. I could call it whatever I wanted to, but I'll just say G sub Delaware. And then to this graph, we need to add our 3 nodes. And we could, if we wanted to, we could name them based off of the county names. So Newcastle was a name of a county, Kent was another name, and Sussex. And then we had a couple edges. One edge connected Newcastle to Kent. And the other edge connected Kent to Sussex. Okay. So let's print some information about this. So I call it the contiguity graph because it tells you which counties are adjacent to each other or contiguous. The contiguity graph for Delaware's counties has these nodes. And these edges. Let's see if it worked. So we indeed have our 3 nodes with those county names. And then Newcastle touches Kent, Kent touches Sussex. Okay. And like before, we can also refer to what are the neighbors of each county. So Kent County is the one in the middle, so it should neighbor both of the other ones. So check that. The neighbors of Kent County are, and I'd like to write this. So the graph's name dot what are the neighbors of Kent? But this isn't actually in a list, or it's not explicitly stored in the graph object, so I have to somehow tell Python to essentially iterate over these things here and convert it into a list. Okay, and it correctly identifies Newcastle and Sussex as the 2 neighboring counties.